Hi everyone, in this video we're going to be looking at the probability of a pair of dice when you roll two dice at the same time. So we know we can use tree diagrams to find the sample space for rolling a pair of die, and then when you find the sample space we can use that to find the probabilities. The tree diagram for rolling a pair of dice is actually pretty big, because the first roll you could get the numbers 1, 2, 3, 4, 5, or 6. And then off of each of those for the second roll, you can also get the numbers 1 through 6. So if you remember from the fundamental counting principle, to find the total number of outcomes, we would multiply 6 times 6, which gives us 36 total possible outcomes. So that's quite a big tree diagram. When we start tracing the branches in this tree diagram, we can get the sample space. And I like to think about it in this arrangement as a square. The first number in the parentheses represents the outcome on the first die. The second number in the ordered pair represents the outcome on the second die. So one outcome I could get is the ordered pair 1, 1. Then I could get the ordered pair 1, 2, 1, 3, 1, 4, and so on. And what's nice about thinking about it as this square is it helps me stay organized in my different outcomes. So now I can analyze that sample space to find the theoretical probabilities. So example 1, use the sample space to determine the theoretical probability of each sum. Write the probability as a fraction. The sum of 2 happens one way. That's when each of my numbers is a 1. There were 36 total outcomes. So the theoretical probability of a 2 is 1/36. The sum of 3 happens two ways. I can get a 2 and a 1 or a 1 and a 2. So that probability would be 2/36. The sum of 4 happens three ways. I could have 3, 1, 2, 2, 1, 3. So that would be 3/36. A sum of 5 happens four ways. We get 4, 1, 3, 2, 2, 3, 1, 4. So that probability is 4/36. A sum of 6 happens 5 ways. 5, 1, 4, 2, 3, 3, 2, 4, 1, 5. So that probability is 5/36. A sum of 7, you probably already guessed it, that happens 6 ways. 6, 1, 5, 2, 4, 3, 3, 4, 2, 5, 1, 6. So that is 6/36. Then for 8, it happens 5 ways again. 6, 2, 5, 3, 4, 4, 3, 5, 2, 6. So it's 5/36. A sum of 9 happens 4 ways. So that probability is 4/36. A sum of 10 happens 3 ways. So that would be 3/36. A sum of 11, 2/36. And a sum of 12 happens 1/36. So you can see there's a pattern in our theoretical probabilities. The denominator is always 36. And when we have the sums in order, they balance out. The sum of 2 is the same as the probability of getting a sum of 12. Okay, so are all of these sums equally likely? No, they have different probabilities. The probability of getting a sum of 2 was 1/36. The probability of getting a sum of 6 was 5/36. What's the probability of getting a sum of 3? So remember, that was a 2 with a 1 or 1 with a 2. So that is 2/36, which we can then reduce to 1/18. I can divide it out using my calculator. 5/100ths repeating as a percent, 5 and 5/10ths repeating percent. And the probability of the sum is 5. So that was 4-1, 3-2, 2-3. So let me start over. 4-1, 2-3, 3-2, 1-4. So that is 4/36, which reduces to 1/9. 1/10 repeating, 11 and 1/10 repeating percent. And the probability of the sum was 9, 5-4, 4-5, 6-3, 3-6. So that is also 4/36, 1/9, 1/10 repeating, 11 and 1/10 repeating percent. I hope this video helps. Please let me know if you have any questions. Thank you.